When the characteristics of a fighter plane are listed, speed is usually among the first qualities. But it is enough to review the capabilities of the ships of the 60s and 70s to see that military aircraft used to be much faster during the Cold War. Have engineers forgotten how to produce awesome machines? Has speed ceased to be a fundamental requirement? In this new video from Military Aviation, we are going to answer all these questions, to discover why combat aircraft stopped being fast and furious. Air-to-air combat was born during World War I. The advantage of having fast and highly maneuverable ships became apparent back then. The fastest ship can strike first and move out of the danger zone before exposing itself to enemy fire. At the start of the conflict, the average speed was 170 km per hour. By the end, it was over 250 km per hour. This trend went on during World War II, and reached its peak during the Korean War. The CT-133 and the MiG-15 had a speed close to Mach 0.9, that is, 1,100 km per hour. The growth curve continued with the development of jet engines with afterburning systems, giving extra thrust that allowed ships to overcome atmospheric drag and exponentially increase speed. Thanks to this, the North American F-100 inaugurated the era of supersonic aircraft. On the other side of the ocean, they were not far behind, with the commissioning of the French Supermystère B-2 and the Soviet MiG-19 and MiG-21. With the introduction of the MiG-25 in 1970, the speed competition reached its highest point. The Soviet model reaches speeds of Mach 3, or 3,500 km per hour, and remains the fastest manned aircraft on the planet. Unexpectedly, the Vietnam War raised several questions regarding the usefulness of such speed. A group of military analysts studied data and recordings from thousands of U.S. air operations in Vietnam, and discovered that the flight record at speeds greater than Mach 1.8 was practically nil. The ships did not need such speeds to complete their missions. When it comes to air-to-air combat, the main quality of an aircraft is maneuverability, being able to change the direction of the plane to carry out lethal attacks. This is related to the radius of gyration, that is, the response of the ship to changes in direction. The higher the speed, the greater the radius of gyration, and therefore, less maneuverability. This is why during the Cold War air-to-air combat occurred entirely at subsonic speeds. Currently, with the development of long-range missiles, combat takes place several kilometers away, so speed has little effect on the offensive performance of modern ships. The maximum speed is also not useful in the section between the base and the combat zone, since supersonic flight consumes a lot of fuel and significantly reduces the operational range of a ship. According to Northrop studies, speeds above Mach 1.1 were useless for these situations. During World War I, high speeds were a necessity for ships to escape enemy fire, particularly ground-based machine guns. But the advance of surface-to-air and air-to-air weapons renders it useless to escape the impact by using speed. Guided missiles have much higher acceleration, so ships rely on other countermeasures to avoid destruction. For clear reference, the AIM-120 AMRAAM missile put into service in 1991 has a top speed of Mach 4, or 4,500 km per hour, far higher than any manned ship in history. Not even the amazing North American State Route 71 Blackbird or MiG-25 could outrun this missile. Over time it became clear that fighter jets could not use their speed to evade guided missiles and anti-aircraft missile systems like the S-300 and S-400. But why run when you can hide? Even better than avoiding enemy weaponry is staying undetected by enemy radar, and that's where stealth technology comes into play. Stealth is a quality that is achieved through multiple means, including the exterior design and angles of the craft, the radar-absorbing materials lining the fuselage, and technology to confuse enemy systems. Speed is not an important factor in this equation, which explains why the F-35, one of the most advanced aircraft in terms of avionics, has a top operating speed of 1,200 miles per hour, but overall it stays at its cruise speed of 1,200 kilometers per hour. Decades have passed, but the speed most used by jets is still similar to that reached by the MiG-15 in World War II. To reach supersonic speeds, some aircraft must resort to afterburners, a process that significantly increases the unit's thermal signature, making it more vulnerable to enemy radars and thermal sensors. The same goes for those that don't use afterburners. Acceleration beyond the sound barrier creates extremely high friction due to the collision between the ship and the drag forces caused by the environment. It is preferable to stay in the subsonic limit to have a much less detectable profile. For these reasons, the maximum operational speed of the F-22 was reduced from Mach 1.8 to Mach 1.6. It may seem counterintuitive, but the Raptor is the most stealthy aircraft on the planet, and it makes sense to foster that strength and not compromise it for faster flying. Designing a supersonic ship, which at the same time has an assorted arsenal of bombs and missiles, is a huge challenge. If we review modern combat aircraft, the weight dedicated to transporting weapons is exponentially higher than those of those ships of the 60s and 70s. The maximum takeoff weight of the F-35 is almost 32 tons, including the 6 underwing pylons with a capacity for 6,800 kilograms, and an internal hold with a capacity for 8,100 kilograms. Russia's Su-35 has 12 wing mounts, to which are added 2 wing rails with a capacity of 8,000 kilograms in total. The higher the weight, the more powerful and fuel-consuming engines are needed. Spatially, there is a limit to the amount of fuel a ship can carry, and one whose operating range is only a few kilometers is of no use. The development of modern warfare seems to agree with the studies carried out during the Vietnam War. Combat ships typically operate at subsonic speeds, prioritizing stealth, detection systems, and the amount of weaponry they can transform. The ships of the future may be a bit faster, but there's no such thing as a race to build the fastest plane on the planet like during the Cold War. If you liked our analysis, we invite you to subscribe and activate notifications so you don't miss our news. We will meet again in the next video of military aviation.